Zoom telling you. All right, welcome everyone to the March 10th Arborist call. Glad to have everybody on. And yeah, we'll get going. We got a lot to cover today. Quick intro. We'll do some status updates for the node implementation, Zcashd, Zcashd. Talk about NU5, development status. Today we're going to talk specifically about the testnet status and reactivation timing. Conrado had asked if we could chat about Windows support, talk about that, and then just kind of have a quick update on Frost and kind of current status and implementations and things. So been a while since we chatted about some of those things. So we'll keep moving. Arborist calls, again, most everyone on the call knows what these are, but for folks that might be hopping into like a random YouTube recording, we get together every couple of weeks to talk about the Zcash protocol. And that's everyone that's interested. We talk about design, timelines, blockers, new protocol research and efforts, et cetera, those kind of things. The purpose is to make it protocol development in particular more accessible and transparent to anyone that wants to participate and the community itself. Speaking of participation, anybody can join the calls, participate. If you want to present, you can let me know. If there's something you'd like discussed, you can also let me know. You don't have to necessarily present it, and we'll get it slotted in. And we have the right team assembled to talk about most anything and everything protocol. So even if there's something you're not comfortable presenting or you don't feel qualified, but you'd love to hear about it, just let me know, and we'll get that slotted in. All right, so we'll switch to the node updates, and I'll kick it over to someone at the foundation on the Zcashd side. Happy to stop sharing if there's something that you wanted to present. Otherwise, I can just leave this up there.
You can leave. Thank you. So hi everyone. So for a status update of Zebra, just to remind everyone that we're currently working on support Zebra working as a backend for Light Wallet D. So our idea is to make Zebra work as a drop-in replacement. So we basically need to implement a bunch of RPC calls that Zcash supports. So we're going to support the same. So in order to do that, we had to do some database changes. Most importantly, we need to, when talking to Aditya, we realized we need to store the node commitment trees for every height, which we didn't beforehand. So we're changing that. And also now we need to store transactions separately. Beforehand, we just store it inside the block. But now, since we have to be able to look up them quickly, we're now changing the database to store them separately. So that's underway. We already implemented some methods like getInfo, which just returns a bunch of info about the node, getBlock, which returns a block, and sendRaw transaction, which receives a transaction inputs into the Zebra mempool. We are already working on some other calls, and we also set up some basic testing infrastructure. We currently are able to start a Zebra node, start a Light Wallet D node, and do some quick testing. But now we're planning to do some testing that using a fully synced Zebra or a fully synced Light Wallet D node. So we can do integration testing, which is for this particular feature that we're working is really important. So it's the only way to be sure that everything is working fine. So yeah, that was it.
Okay. All right, excellent. Yeah, that I mean, probably others knew. I had seen a random, kind of a message here or there from folks about if we were going to add RPC support. I think the first one I saw was like Zget tree state or something for Orchard, and I assume that was kind of related to some of the Light Wallet D work because it was asked in that channel on Discord. So very good, excellent progress. So moving on to Zcashd, we at this stage our Zcashd update is the NU5 update from our side because that's literally all we're focused on. So we don't have a specific section there. We'll just kind of move into talk about NU5 itself. A couple slides I always throw up, and again, this is really just for posterity. For folks that may not know, these are the new zips in NU5. And by the way, all these are out on zips.z.cash. You can, excuse me, see the same list basically. Here's the updated zips. These are zips that we had to just kind of make some, let's just say an amendment for Orchard, for example, like zip 209, not letting pool balance go negative, for example. We just kind of added Orchard verbiage into there. Ditto for some of the other ones. So the first thing up, I want to talk about the testnet status and reactivation timing. So I'm actually going to stop sharing my screen, and that way we can kind of see each other in gallery mode. Then I'll throw some things back up. Oh, hey, Deirdre. You joined after I started presenting, so I couldn't see who joined. Yeah, so I want to, Strad, you want to lead this part of the discussion?
Yeah, sure. So, yeah, anyone who's been using testnet will have encountered some weather recently, rather unfortunate weather. So we published the first Orchard note on testnet a couple of weeks ago. And shortly afterwards, that uncovered a bug in the Zcashd implementation of the consensus rules, which was allowing, in certain situations, a node to get confused about the Orchard commitment tree in sort of rollback situations. And it just so happened in that rollback situation occurred because right after someone, right after we published that note, someone turned on a rather large miner and caused a reorg that triggered this bug, and that basically caused a cascade failure of testnet. So things aren't great there at the moment. We have a fix in Zcashd, but we can't actually reliably use testnet until basically everyone who is trying to mine on testnet is on latest master. So yeah, we're basically just taking the view of we're going to be rolling back testnet anyway for 4.7.0, so let's just get 4.7.0 out to roll that back. And then as soon as people start installing 4.7.0, that will include, as part of doing the rollback, it will detect that it's essentially rolling back to before NU5 activated on testnet, so all of the problem branches will go away. So that aspect is going to occur like as soon as we can get it out. But that sort of then leads into, okay, well, we want to get that out as soon as possible. Combining with that is, okay, that release needs to set the testnet reactivation height for NU5. So it's basically where testnet is at.
Yeah. So if you happen to be running on testnet, the first Orchard output was in block 1779, 174, 175.
Something like that, yeah.
The reorg point was 1779, 198. And now there's a couple of forks that are like 9,000 blocks, 9,000 blocks diverged.
And it's correctly triggering the behavior that we added to Zcashd years ago, which is if it sees a reorg of over 100 blocks, shut down and ask the user to help. Because if we ever saw that on mainnet, that is a big problem. To the point that like Zebra is also like helping to solidify 100 blocks rollback as the this happens, and it's like, no, we stop things and take a look and figure out what's going on. Unfortunately, testnet mining power is unstable enough that this kind of bug, which is like the sort of thing we have testnet for, unfortunately results in significant breakage of the general testnet. Which is partly why things like testing to the box are also useful, because then you're running in your own environment and you get to isolate what's going on.
Yeah. So, reg tests. I mean, you can like with Sean and I are synced up on a testnet, one of the forks, and I mean, we've been running for days. So, I mean, if anyone needed like a testnet node to connect to, you could connect directly to one of us. But I mean, reg tests also works incredibly well. In fact,
Yep.
arguably, it works even a little better to test if you're doing development. So that's good. But yeah, so we'll get all that cleaned up. Now, naturally, when we hit that, it was, it's not immediately obvious what caused it. So, we spent actually a fair amount of time over the last sprint, one, troubleshooting it. Strad built some tooling to definitively pinpoint it, because we wanted to be, we kind of found in a super pairing, Dara, Strad, Sean, and I was just listening. I contributed nothing. Basically what we thought it was, but this is not the kind of thing you want to go with what you think it is, right? You want to know definitively this is what caused the problem exactly, and we wanted to be able to verify the fix, so we built some test cases for it. So long story short, testnet's not in a great state. We do know the fix for it and have that in place. It's in master, as Strad mentioned. And then the next thing we wanted to chat about in combination with this is we'll talk about 4.7.0, which is the release that will include this, for people that's tagged essentially. But reactivation timing. I know at one point some folks had asked if we could have like 2 weeks between when we picked that height for reactivation and we actually did it. That was obviously prior to testnet. I mean, it's usable, but it's not like, super usable. So anyway, I wanted to throw that out. We're hopeful that we'll have a release candidate for 4.7.0 early in the week, next week, and then potentially the release later in the week if all goes well with remaining work, which I can bring up in just a moment. Anything from the foundation, like on preference for reactivation timing or anything you want to discuss about that? I mean, we'll coordinate async in Discord, like, hey, what about this? What about that? So not a specific block height today, but just in general, like number of days or timing or whatever.
I don't know, Conrado, do we have any preference? I don't think we do, really.
Yeah, I don't think we do. I think our biggest worry is to have time to know if we update some dependency and something breaks, we have time to fix it. I think we fixed a lot of stuff that changed recently with the Zcash script changes. So yeah, I feel like there isn't much risk of other stuff breaking, but I'm not sure. But yeah, I think having 2 weeks would be best, but at least 1 week it would be really good.
Yeah, the NU5 consensus branch, the only changes left for that, other than obviously like merging master in and things, but like what's in the NU5 consensus branch for Zcashd, the only remaining changes are, changing the consensus branch ID to whatever is decided for the new set of consensus rules, which will be decided by someone's RNG soon, and then the new activation height. So probably what I'm planning on doing is updating that branch to remove the activation height and change the consensus branch ID, which then will obviously change, signature validations and all that sort of stuff, because the consensus branch ID is changing. But that should be I think the only thing that might the only thing that would affect Zebra, because the activation height stuff, I don't know if you're using any of the actually, no, the Zcash script library, I forget the details that it actually takes in a height on. I think it just bases it on transaction version. So yeah, there's no height information there. So yeah, I think you're fine from that perspective in terms of there's nothing in the Zcash stuff that is network upgrade specific. It's transaction version specific. And then as far as I'm aware, you don't use the consensus types in Zcash primitives. Like you use like the legacy script stuff and whatever from Zcash primitives, but as far as where you don't use the stuff in the consensus module within there because you have your own implementations of that.
No, yeah.
Okay. So then any like whatever activation heights and things that sit there won't affect you. Okay. So yeah, and you've already been testing with the NU5 consensus branch and the crates it uses for the Zcash script library and downstream, right?
Yeah, I basically got that PR that with the Zcash script API change. So I'm using that and everything that it uses, right? So all the orchard and
so that means
Zcash.
that means you'll be testing against the intended consensus rule sets. That's
right.
good. But you shouldn't have any other than updating pinned revisions to whatever ends up in 470. You shouldn't have any dependency differences from what you're currently testing against.
Got it. Yeah. So
unless something like terrible happens in terms of like trying to fix dependency resolution hell at the last minute or something, in which case we'll let you know.
Sure, thank you.
I hope it won't happen, but you never know. Someone upstream could like push a point release that breaks MSRV again or something.
Yeah.
All right. Okay. So we'll just coordinate in Discord. Like I said, we're hoping to have and I'll get my screen back up actually while I'm talking. We're hoping to have a release candidate pretty early in the week if everything goes well. Okay. So we talked about that. I'm going to just go to the next slide. So remaining work for NU5, and I'll go back. I guess everyone can see this anyway. I just wanted to bring our DAG up. Essentially, here's the list of things we have to do between now and NU5 activation. The main thing, of course, is the next immediate thing is 470. 470 in summary is kind of remaining unified address orchard support in Zcashd, which is the wallet and let's just call it generically transfer support, meaning I can use a unified address that has an orchard receiver in a Zsend mini, for example. And then all the other multitude of RPCs that would potentially be using unified addresses in Orchard. And then we're making pretty good progress with our ecosystem partners. They're already working in parallel, some exchanges, the miners, et cetera. So making good progress there. And then of course, as we just discussed, 470 will essentially reactivate testnet, returning it to a workable state. The security proof, so post 470 in parallel, the next two are already in progress. The security proof sign off by Mary Mahler. Sean and the team, Dara's been working some with Mary as well, but they've all been kind of collaborating on that review. There's a lot of back and forth there. So, but that's looking really good. We don't anticipate any kind of issue that pops up out of that. And then one of the things that we've kind of put on ourselves before 500, which sets mainnet activation height internally for Zcashd, is another internal review of the Orchard circuit and the consensus rules and logic, consensus rule implementation, consensus logic, if you will. That came from, that's just, we do that anyway. We found one bug post Kedit audit, post NCC audit that we fixed in 460-1. So we, Taylor's already working on that. Some of the core team members have been working on it too, in between, PR and PR review. And we feel good about that. We don't expect to find anything, but we're going to do it, kind of an exhaustive pass through everything. And then we're looking for a thumbs up basically from everyone on core and Taylor and security. So we'll do that. Those are the two bullets, 2 and 3 are the gating factors for release 500, which sets, would set the mainnet activation height on the Zcashd side, that is. And then that should be release 5.1.0. It's just the second Zcashd release that's in U5 compatible. We EOS halt releases that are not compatible with the consensus rules that will activate. So, and we always like to have 2 releases in the field that support any given network upgrade, if at all possible. So in this case, we'll produce a 510. The delta between 510 and 500 who knows, maybe fix up some help text and RPCs or clean up a few things here and there. We've got it in the DAG anyway of things we need to do, but no major functionality, if you will, between 5.0.0 5.1.0 that we're aware of at the moment. Just for reference, this is kind of our current DAG. DAG is what does it stand for? Direct acyclic graph.
Yes.
Directed acyclic graph.
Yeah.
So this is a cool thing. It's at github.com/zcash/developers. It works with ZenHub and also GitHub. It uses the APIs in both to kind of, it kind of runs off GitHub API information for the most part, and from ZenHub, if you've ever used that, which I know the foundation does, it pulls in let's call it dependency information, like issue A is blocked by issue B and B blocks C, etc. So what you get is kind of like a pretty nice graph of dependencies and what's most important to work on. Strad did an amazing job with this tool, by the way. So we literally use this in our stand-up. This is what we put up for stand-up now. We used to use the board in ZenHub, and we still use it, but this is kind of a summary. We use milestones for sprints in ZenHub. So the blue box is around our current milestone, the core sprint 2022-08. But we can tell, for the release candidate, here's the things we have in flight at the moment. The difference between the blues and the greens, just FYI, in case anyone's wondering, blues were in the sprint when we started. So we did our sprint planning, we committed these to the sprint, and the greens are things that we realized should be in there after the sprint. And that's just kind of a good way to go, oh, there was, whatever. We need to do a better job sprint planning because everything's green at the end of the sprint. It either means you closed everything and added it to the sprint, or you forgot a bunch of stuff at planning. But for what it's worth, the point of this is that's the subset of things we're working on for the release candidate, which we hope is, again, early in the week. That feeds into the actual release. And the bulk of this is just like publishing some crates, a little bit of cleanup, consistent naming, pool versus type, and RPCs, clean up some help text. So, not a lot during the release candidate period, which is, again, by design. Like, you want to test the release candidate thoroughly and then really not change it much before you pump out the release. So
it fits on a single screen for the first time in quite some while.
I know, which is really nice. So yeah, it's when you can like look at it without scrolling to see the work, either left or right or up or down, then it's like progress. Anyway, so that's what we have left for 4.7.0 for the most part. So any questions about any of that before I move on? Yep, there's a hand from Conrado. Yeah, go ahead.
Yeah, I'm wondering what is the time between the testnet reactivation and mainnet activation?
Well, it's a good question. At this stage, we're going to kind of take things like step by step because we're getting so close. If, for example, we would like the answer to the question was we'd like as much time as possible between testnet reactivation and mainnet activation for a lot of reasons. It gives you more time to discover bugs or partners to test or whatever. So we're just going to kind of heads down focus on doing everything we can to get 4.7.0 out next week. And then I think when we cut the release candidate, we can probably pick the testnet reactivation height at that point. I think that'll be a pretty safe kind of a thing to do at that point. So we don't have to wait necessarily for the release to come out, then pick a week, post that. So I don't like this Arborist call. I do not have like graphics that show timelines. We have timeline fatigue, so we're tackling the thing that's right in front of us and doing it as well and as fast as we can. That's probably not the answer you're looking for, but that's about all. That's about all we have left in the tank at this point to answer with is that. So
it's fine.
Yeah.
Thank you.
Yeah.
So last year we talked about having 2 months between testnet activation and mainnet activation to give wallets and whatnot time to test properly and so on. Is that still the sort of thing that we're looking at?
Unlikely.
Yeah, I mean, we've been like, you can, like, we're working with, partners now that are testing, let's just, I don't know, call it compatibility mode, right? Like, does your stuff still work with like B5 transactions and, things of that nature, zip 244 changes.
And then we do have people who have been testing against their own local, like private test nets, effectively in Ridge test, against the NU5 consensus branch.
Right. So that, I mean, ideally, if we were just delivering everything to testnet with 470, then yeah, for sure, we'd want at least two full months. Given that we've had, we've kind of got the compatibility part out of the way, partners are making progress in parallel, testing the new consensus rules, as Strad mentioned. I definitely don't think we need 2 months from testnet reactivation till mainnet activation. So for now, we've got the same targets, and we're just, again, honestly, for a little bit of our own mental health, we're just kind of focusing on the thing right in front of us. The team was getting a little bit worn down.
I don't think the current dates are likely to stay where they are, but I think we'll be in a better position to establish where they should go when we have 470 out.
So and again, if there's some significant delay in 470 for whatever reason, like we realized there was some additional work we didn't account for, then that obviously impacts things too. But as Strad mentioned, the reason there's kind of a focus on 470 is that will be, to the best of our knowledge, except for kind of clean up to help text in a random RPC or something we want to introduce net new, that will be the bulk of the functionality for NU5 in that release. So we can have everything out there, everything being tested, and then we'll kind of know, okay, what is in front of us is simply partner support and cleanup for the most part. All right, other questions? I haven't been keeping up with the chat, but I didn't see anything pop up there. Okay. All right, we will move on then. The next thing that we had on the list, I'm actually just going to stop sharing so we can all see each other again. Conrado had asked in the Discord if we had time today, if we could talk about Windows support. So I'll just kind of let him discuss what he was thinking about there. I mean, obviously, I think we kind of know what that means, but yeah, I'll just let you go ahead and kind of kick it off.
Sure, thank you. So basically, Zebra uses the Zcash script code to validate transparent transactions, and for that we have a crate, also called Zcash script, which is confusing, which wraps that in a Rust crate, right? So basically what happened is I was updating to the new Zcash script, which supports V5 transactions, and our Windows build broke. So investigated a little bit, it was some strange error, but I noticed that we were using Rust with the Visual Studio compiler. So Rust on Windows supports both Visual Studio and MinGW, which is GCC for Windows, basically. So I found that odd. I switched it to GCC, which sounded more likely to work, and it worked. But when I tried to link that with Zebra, I realized that we use another library for the database, which is RocksDB, which only supports Visual Studio, but does not support GCC. So basically what that means for Zebra right now is that we can't support Windows anymore. So since, we just need to keep working on stuff, and Windows is not a higher priority for us, we just dropped the support. But I'm wondering if the Zcash, I mean, I checked the documentation, it says that Zcash does not support of Windows officially, but I'm wondering if it's something that you think it should support. Go ahead.
We use Clang to cross-compile to Windows from
right,
Linux.
so
it works.
But is it enforced, right? It's like it's tested the CI, you make sure that every
right.
we don't have we don't have tests in CI, because that's been the blocker all this time, has been the inability to run our test suite in CI, is why Zcashd has never had official Windows builds. But building has for a long time been checked in CI. I don't know if that is exactly currently the case, but
I mean, I haven't tried to
yes,
run it.
yeah, we do indeed check that Windows builds. I've just confirmed in our CI.
I haven't tried to run it on a Windows VM for a while, and I don't have hardware that runs Windows.
Yeah. Do you? So the only thing that we will we've gone in pretty heavily on, we pin Clang, we pin Rust, and that's what we support. I've not at all investigated like Clang plus MSVC in terms
I think
of
it's supposed to work, and you're supposed to be able to link.
I went for MinGW because it was the approach I could get working.
Yeah. You've got to be very careful about the C++ standard lib compatibility. I think it's
Well, we pin we use lib C++ directly from Clang, so we don't use the lib standard C++ from GCC or whatever else happens to be around in the system. The only exception I think is on Darwin, where because we use the Clang provided because Apple is weird, we use the Clang and I think libcc from the system, but I think that's the only exception. I think everything else we use the pinned versions for.
Right.
So you wanted to be able to link modules compiled with C++ with.
I know that's possible to link libraries with different compilers, but I also know from personal experience that things can go wrong with that.
I think the issue would be compatibility of VC++ compiled code with libc++, and I'm not sure about that.
Yeah, what I'm wondering is if we decide to restore Win support, and probably the easier way to do that is changing Zcash to compile with Visual Studio. Would you be interested in changing that if you did the changes, and maybe even we can help testing on CI with Windows with Visual Studio? Is this something that you're interested in doing?
If we can figure out how to get that setup working, then sure. I think it would be essentially differentiated by host target. Because currently, the way we compile that is just target the x86-64, W64, MinGW32 or whatever as the target. So if we are just adding another target, but that target is MSVC, then no, I don't see a problem with that. It would still need to be the question basically becomes, is it that we're changing it specifically to work with libc VC++, or is it that you want to compile with the Microsoft C++ compiler? The latter is I'm less happy about.
I mean, is it that you want to use Visual Studio Code because that works fine with Clang?
No, that's not the problem, Derek. The problem here is so what we essentially want is that the subset of code that is used for libzcash _script, the C library that is produced when you compile Zcashd with libs flag, that subset of code needs to be able to compile in a way that is compatible with RocksDB. And currently there is a bug that causes it to not do so.
Yep.
So I have no problem merging patches to make that work. As in to fix the bugs in the C++ code that prevent the compilation going. If what you actually want is Zcashd to have the ability to just always compile with Visual C++ and and that be a supported thing, I don't think that's something we will support ongoing. But if it's something that you want to like keep, as a tested form in the Zcash script library, and this partly comes down to the way in which the Zcash script library pulls in and integrates with the subset of the Zcash repo that contains libzcash script. If we could figure out a way to make that more modular, that would also help here. Or alternatively, have a way for like changes on our side to trigger CI on your side that verifies nothing's broken or something like that, so we can identify where problems occur.
Is there a ticket that describes the problems with?
No, I haven't created yet, but I also was not sure if that's something that you were interested in, fixing, compiling the issues that.
I see an issue on the RocksDB GitHub issue 1920 there.
Yeah, they have a PR for
support.
Yeah.
If the fix for you is we merge some changes to the code to make it work for you, that's fine. Don't have a problem there.
Right.
If the fix becomes we need a different compiler to be officially supported alongside Clang, that's a different conversation. Which at this time I don't see a strong motivation for, and I would need to be convinced of.
Sure.
Yeah, like one of the motivations for standardizing on Clang was that we were standardizing on an LLVM backend between Rust and C++ code, both for just like stability and sensibility for the compiler stack, and also LTO optimizations when I eventually managed to get that going.
Tayor, your hand's up.
Yeah, so I just wanted to answer a question from the Q&A. There's a question asking about Zcashd and Windows. So the answer is there are multiple compilers on Windows that we could use. Zcashd works with one of them. Parts of Zebra work with one and parts work with another. So no, Zcashd will continue to work with Windows and there's no problem there. Zebra, we have to make a few fixes to a small part of Zcashd that we share to get it working again.
Okay. Yep. Okay. Thanks. I had the window up. I was about to bring that one up, but cool. All right. Thanks. Yeah. Thanks for that. Conrado.
Also, just to remind everyone, I think this is also some feedback that we like to receive. If people are interested in the Windows support for Zebra, so if you feel strongly about that, please reach out so that we can prioritize this or not.
Oh, okay, cool. Yeah, good point.
Yeah, I am all for Windows support in general, and I'm all for enabling it. I am also for manageable, supported build processes.
Right. Cool. All right. Okay. Tayor, did you have something else? Okay. All right. Excellent. Okay, let's see. All right, I think we covered that one. The next item, we just kind of wanted to have a brief Frost update if someone wants to hop on and do that.
Cool. I'll give an update here, and then Chelsea's also here, and she can fill in anything that I miss or get wrong. So for those not aware, Frost is a flexible, round, optimized Schnorr threshold signatures. These are threshold, not multi-sig. A lot of people call them multi-sig, but they are T of N possible signers to create a signature that happens to be compatible with the signatures that we use in Zcash, amongst many others. There has been a paper that Chelsea and her co-author Ian Goldberg put out almost 2 years ago now, I think, that several people have found very attractive, and we've seen multiple implementations sprout up around the internet using Ed 25519. We wrote two for Red Jub Jub. We've seen for Ristretto, and we've seen some that are trying to do even more exotic curve groups out in the world. Unfortunately, I think all of them are not compatible with each other, so we're working on a draft. an IETF RFC, and I'll share what we have on that.
Oh, cool.
Over here. And if I'll make this a little bit bigger so people can see. So this is the repository where we are working on the draft, and we includes myself, Chelsea Conlow, Chris Wood from Cloudflare, and Isis Lovecraft has collaborated with us on some implementation stuff. And some other third-party contributors have popped in here and there, including a C implementation that's been contributed from a contributor that we did not even know about. They found us, and they have put in a C compatible implementation with version 2 of the specification. We just cut and submitted version 3 of the spec draft to the IETF CFRG, blah, 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 the last week. We weren't sure if we were going to make a couple more changes to that draft. We were trying to get it in before the next IETF meeting deadline, blah, 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 but we think we're pretty solid with version 3, which is the current version that's up now. This is a rendered draft for that. This URL is also linked from the repository. So we have, just to tell you what's in the draft as opposed to not, or what it was just in the paper or something like that. So there are several options of how to run Frost in the paper. Some of those include Frost 1 round with pre-processing, or 2 rounds, or there you could read into it a possibility of 3 rounds depending on who took which roles or whatever. So this draft is specifying 2-round Frost, which includes everyone has key shares, and we have information about how you can distribute key shares. There's multiple possible ways, but once you have key shares, you do a round of commitments. Everyone who is a possible signer, who is participating in a signing with Frost, has a round of commitments to nonces that they don't reveal. And then everyone signs using those commitments and produces their share of the signature. And then an aggregator takes all of those shares and the previously shared commitments that are commitments to the part of the nonce that you're contributing to for this signature, and produces the aggregated signature, which is indistinguishable from any single party generated Schnorr signature, which is an excellent thing to have for a privacy protocol like Zcash or any other, where you don't want to be able to distinguish a single party Schnorr signature, which is what we have now, or a multi-party threshold signature. They look the same and verify the same. So that's the nice thing about this thing. It's quite simple. I think we have 3 security proofs in different places, in different states of the different security properties of Frost, including the one that Chelsea has created with her co-authors. We're feeling pretty good about Frost as laid out like this. And part of the reason we want to point people at the specification is that there are a lot of sort of left up to the reader decisions you would make if you're just trying to implement Frost from the original paper. And we make a lot of those decisions for you, but we also provide a lot of Cipher Suites for you with a lot of these decisions made for you, such as like how you domain separate, generation of things from public data, like what are the context strings that you are using for specific Cipher Suites. Like this is why there are at least 3 implementations of doing Frost with Ristretto, the prime order Ristretto group, which is very fast, but they're all, well, not all. Now that when they started, they were all non-interoperable because they all did these things slightly differently. And so they would not work with each other or verify each other's signatures or signature shares or all these pieces correctly. Now, the one that I've been working on and the one that is Sage in the repository, the sort of proof of concept reference implementation, those are interoperable, so yay. One of the nice things about the draft is that we have test vectors for all of these Cipher Suites, including—
I was just looking at them. Yeah,
yep,
they seem pretty thorough.
So if you have a shared secret and you split it up and you have a message, you should be able to generate, and you have, different shares of that shared secret, and you generate these nonces. You should generate these commitments. And then when you use those commitments to sign, you should generate these signature shares. And then when you combine all those signature shares and verify it with the previously generated commitments, you generate this signature. And you can go through all those pieces to make sure that your implementation is doing all of those pieces correctly based on known starting values and stuff like that. So the 4 Cipher suites we currently have defined are ED2 5519, trying to be compatible with the previous RFC narrowly. We're not trying to be I think it's like RFC 8032 or something like that. That defines how you do signatures with ED2 5519. We're not, that has a lot of options in that draft. We're trying to be narrowly compatible with that. This is why we have a ED2 5519 Cipher Suite and a Ristretto Cipher Suite, because people who may know Ristretto and ED2 5519 are very intimately linked, but Ristretto signatures are not equals ED2 5519 signatures according to 8032, the RFC 8032. That is why the 2 of them are existing in one, specification. We also have ED 448, which is very similar to the ED2 5519. And then we have PEAT56, which is a, old school, very popular, very common NIST curve that's widely available. And this is not an ECDSA signature on PEAT56. This is a Schnorr signature like EDDSA on PEAT56. Yeah, and the Strat is giving a thumbs up. Yeah. So all of these things are Schnorr signatures, not ECDSA signatures, even if you've seen these curves or these curve groups used for ECDSA signatures elsewhere. And I say that because we've batted about specifying doing Frost Schnorr signatures with the Bitcoin curve, SecP56K1. We haven't done that yet, but we've batted that about, and it would look very similar to what we're doing with the PEAT56 group. So that's right. Go ahead. Yeah.
I just want to jump in really quickly, just to kind of, for those who are confused about ECDSA versus Schnorr versus whatever else is out there. So when we say Schnorr, we mean signatures which are compatible with EDDSA verification algorithms.
Right.
So what that means in short is just like off the top of my head, basically the signature that's put out there is compatible with EDDSA verification algorithms, which are specified. And that's basically just that you hash in the public key. For those who are confused about the terminology between Schnorr versus EDDSA. ECDSA is a completely different signature algorithm.
Yep.
So go ahead.
Okay. So RedDSA is a Schnorr family signature, but is not compatible with EDDSA. Do you intend to add any Cipher Suites for RedDSA?
How is it not compatible with EDDSA verification?
It just details of how the
randomization
hashed, I think. No, it's so EDDSA, the private key is hashed differently.
The private key is deterministically generated, right? So what we have is not compatible with signature generation of EDDSA. It is
right.
It's not deterministic. Deterministic Frost is very broken. Do not ever use it. So it strictly has to be randomized, but it is compatible with EDDSA verification. Just to kind of clear that up.
Okay, so it would be possible to define a RedDSA compatible one then.
Correct. Yes. Yeah. And we have one already.
Cool.
Yeah.
Oh, okay. I just didn't see it in the Cipher Suites though.
Yeah. I don't know if we are planning to have Red Jub or Red Palace as a Cipher suite for this IETF RFC, but we'll probably, if we want to, we'll probably add notes to be like, if you want to use this in specific setting, like this is how you do it or something like that.
I mean, I would quite like Red Palace and Red Jub to be in the draft, and I'm happy to do the work to add it to the draft if
part of our constraints, at least so far, is we've been pointing to curve groups that have already been defined in IETF documents. So Pete 56, Ed 448, Ed 25519, and Ristretto are either already approved full RFCs or have longstanding IETF drafts. I think Ristretto is like, hey, this has been sitting here for years. Let's finally getting over the finish line. So that's been part of our why we picked certain things. But like part of the motivation for a lot of our implementation is we implemented Frost over Red Jub first, or at least I did. We are always keeping in mind, like, we want to use Frost to generate signatures used in Zcash. So that includes, we want to make sure that we can use a good, well-specified and compatible version of Frost to generate Red Jub and Red DSA signatures, even if they are not, those parameter sets are explicitly laid out in this document, because they may be laid out in a zip, for example.
Yeah, I suspect that's probably going to be the right place to put that.
Yeah, they should probably be in a zip, to be honest.
Dara, did you have a question earlier?
No, that I can put my hand down now.
Okay.
I had, go ahead. Sorry.
I think I was just gonna wrap up where we are. So we just cut version 3. I said before that we weren't sure if we were going to add some stuff to that, but we basically, I think Chelsea and the original co-author, her original co-author in the original paper, Ian Goldberg, took a look at the current version, and we're pretty satisfied with it. So I think we're gonna basically start saying, look at this version of Frost to kind of the IETF, the CFRG, the Crypto Forum Research Group subdivision of the IETF, as the one that we're trying to coalesce around. So our implementation of Ristretto Cipher Suite is compatible with version 2. I have to make some tweaks to make it compatible with version 3 and the latest test factors. And our code, I've been working solidly on Frost for at least 2 months. I think I'm going to clean up some code to make it a little bit more reusable for Red Jub and any other Cipher suites we want to implement in our code base. The foundation's code base is here, Zcash Foundation /Frost. I talked with our project manager, Fungi, earlier this week about, we have dribs and drabs of Frost related code in multiple repositories. We have some Red Palace compatible Frost code in the main Zebra repository. We have old original version of Red Jub Frost in the Red Jub repository. We have work we want to do to upgrade the Red Jub repository into a Red DSA repository. There's a lot of cleanup around there about old Frost code. This is where the up to date with the spec Frost code that we are working on is going to live. And you can kind of tell, like, we have the Ristretto crate and we'll have a Red Jub crate and so on and so on. So that's where we're doing our implementation work from the foundation side. And we will be keeping track of known implementations of the spec that are compatible with the spec, at least, in this README table with the repository. So that's the Sage Python code that lives in that repository and is generating the test vectors that are in the spec. Ours, the Ristretto variant that's in Rust, this C library from this person that we're not even sure where they're from, but they're doing a good job and they're very responsive. We know that ISIS Lovecraft had their own implementation of the Ristretto Cipher Suite in Rust. It has also fallen behind compatibility with the spec, but I think they're working to bring it back to compatibility. And I think they're working on another one, but we'll see if that actually comes up. So if you're interested in Frost, please stay up to date with this specification, because this is getting the most, like, I don't know how many times I've implemented Frost at this point, like multiple iterations of Frost over and over and over again. We're answering the questions that implementers may have as much as possible so that they don't have to answer them themselves in the work that we're doing in this repository and this draft. So please follow along with the draft and implementations there, and ask us questions on like open issues and things like that about that. So Chelsea, anything that I missed? Anything I got wrong?
Yeah, so I think like any research paper, it's never like, it's a proof of concept, right? So you're never gonna like answer exactly what people need to implement. So there shouldn't be any surprises about why this draft exists. This draft exists for people who actually want to implement it. So I'm pretty happy with where this is at. Having many eyes on this has been extremely useful. With just like any new research, it's extremely helpful to have something very public that lots of people are looking at. So that's been great. I know there's been questions about, okay, what does use in Zcash mean? What it means is I need to write a proof for re-randomizable Frost. I know how to do that. I need to do that. And then we'll be moving forward. But I think it's great that this draft is there, because it means that there's just going to be wider review, and I feel much more comfortable with the security claims and with our implementation and everything. So
cool. I had a couple of questions, like super high level, actually. Is it kind of for Strat, actually? Is this similar? Like, so you had the paper for Frost, and then people like took the paper and like, oh, let's go implement that, and then their implementations weren't necessarily compatible. And so now you're working on the spec, which is kind of what, I mean, obviously different kind of tech, but it's what you ran into with Poseidon, right? Like you noticed Poseidon implementations were a little different.
It's exactly the same thing. The problem with the Poseidon side is we haven't had the time to do the work to get the specification in place. For the wider community. Made a start, ran out of time to continue it. So no, it sounds that like Frost is in a much better position from that perspective.
Yeah, I thought, again, I don't know the specifics of the technology, but it sounded exactly like the same kind of thing conceptually. And then a second question, I see Dara's hands up too. I've never really worked with like IETF. How long of a process is that to get something accepted by them, or does it kind of depend?
It depends.
I thought that was the answer.
If you stay on top of it, you can push and push and push until you finally get it through the door. But it requires you to basically stay on top of it.
Got to be active.
It also depends on how functional or otherwise the working group that you're in is. So for example, I've been in working groups that were pretty okay, and I've been in working groups that where everyone was literally at each other's throats. Well, no, not literally, but the international domain names working group was famously dysfunctional.
Go ahead.
I was going to jump in and say, like, I think we have a pretty tight team, like between Deirdre, Chris, and then Isis helping out. We're fast. Our goal is to have something that's complete and ready for review by the summer. Obviously, that doesn't block internally within Zcash our work to move this forward. But what's nice is having an IETF draft means that more people are paying attention, so things are fleshed out. But I think we have a pretty power team right now, and everyone's focused. So
awesome.
So that was also. Oh, go ahead, Derek. Sorry.
I'm just looking at Chanel's signature verifying the draft. The only difference I can see from the red DSA verification is cofactor multiplication. So the IETF draft does not have cofactor multiplication. Which only applies to JubJub.
Right. I think we have an issue open explicitly about that, specifically just for Schnorr, sign and verify, so that sign and verify are compatible in single and batch settings. Luckily, the Frost specific procedures don't have to worry so much about cofactors, because a lot of it is encapsulated with, you define your group, and if you're Ristretto, you define your group about how you like do your thing, and if you're not, the only place you do, like if you're ed 25519 or ed 448 or red jub or whatever, you care about your cofactor in that verification. And that's it, which is very nice for us. But there's an issue for that, and we just have to do that. But because it's like not explicitly the Frost stuff, it's kind of fell later.
But it's obviously not a problem for like Red Palace or some of the ones, because they're coincident, which is lovely. Yeah, I'm already thinking ahead to like what this is going to look like for Zcash usage. I'm imagining that the workflow here is going to be, we take like individual Frost compatible UA, i.e. something that contains either sapling or orchard addresses, and you'll be able to produce via the key generation process or the setup process a single address or single viewing key effectively that maps to the particular protocol, which means we need like type codes for Frost variant. Actually, we might not need variants for those, because you might need Frost variant for like at the viewing key level, maybe. You would need somewhere to store the Frost components of what you're dealing with.
There is a group verification key. Whenever you generate a main secret, so we define two ways of setting up your secrets and your secret shares as basically appendices in this RFC. Trusted dealer, where a dealer generates the shares, gives them out, and verifies that the public key associated with the original secret is good, and that the thing that you generate at the end is verifiable by that group public key. Or distributed key generation, which basically achieves the same thing, but you have to do a couple rounds of work to make sure everyone gets the appropriate shares. And this is all Shamir secret sharing and blah, 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 blah. We are able to produce the group public key, and that is basically indistinguishable from a singleton
verification. Fantastic. We don't need to do anything different for UVKs then, other than
that's really nice.
Other than these will be UVKs and UAs that aren't derived in an HD way effectively. But but that's fine. That's intended and expected.
At the very least, the first stab I would envision is do trusted dealer, which is it's just do everything the same, but with a trusted dealer to split up the shares, and you're set. And then the harder one is distributed key gen. But we can, it's very easy to just slot in trusted dealer into how we generate keys and UVKs and all that stuff in Zcash currently to do this.
Cool.
I have a question about distributed key gen. How much information needs to be passed back and forth in the distributed key gen process? I'm just sort of wondering whether distributed key gen could actually be executed over Zcash memos.
Ooh, it's not a ton. Go ahead, Chelsea.
Yeah, I'm just going to jump in. So distributed key gen is generating a shared secret key among trusted parties. So it's a secret signing key. I don't know why you would do this over a blockchain. Like, it would be between like parties that are going to sign transactions in the future. So generally, this is kind of like a sensitive operation that should be done infrequently. So generally,
my question is really thinking about how one might integrate threshold signatures into wallets. If the wallets need to collaborate to generate their shares, whether that collaboration phase could be done over shielded memos.
It could. I mean, it's like rough. I mean, off the top of my head, the overhead is like a few scalars and then T group, or T plus or minus some constant group elements, where T is the number, is the threshold. So the communication overhead is small, but I mean, you need a private channel anyway for sending shares, right? Because you're sending secret shares around. I don't know. I'm not a UX person, but if you think about keygen normally, like you have all the issues of like if one party goes offline or if one party never responds. So I think generally probably not doing it over the blockchain is a...
Yeah, there's multiple rounds. So every time so distributed keygen is everyone basically has to talk to everybody who is distributing a secret. So if you're doing it, the smallest that makes sense is T is 2 of 3, where 2 is the threshold of 3 possible signers. All of them have to get all the pieces of distributed keygen from each other over a secure channel, and then they can start the 2 rounds of frost signing. It's possible, but it sounds annoying. So I envision you could do a DKG over Signal with QR codes with your friends in a group if you really want to. And then when you have all of your shares, you feed them into your Zcash wallet or something like that. Or someone does trusted dealer and just says, here's all your shares. I promise I'm deleting the original shared secret or something like that.
I mean, I think I literally once hacked together like a party sign Python app that just used magic wormhole to set up a bunch of pipes from one person to everyone else, and then one person was just doing the sharing and stuff. So that also works. You just need an ephemeral direct connection, and there are fortunately a number of ways to achieve that now. You know, either like Tor hidden services or Tailscale if you're in an organization.
Cool. Any more questions?
Actually, now I'm imagining just directly using like bundling user space WireGuard and back channeling off the Tailscale's derp network.
Yes.
In the wallets just to like just bootstrap some direct connections and be done.
All right. I think that's all I didn't see any more questions in chat or anything. Thanks for that update.
Yeah.
Anyone have anything else before we wrap the call up? Nope, doesn't look like it. All right, everyone have a good rest of the week, and we will catch up async in Discord and keep moving forward. So, all right, see everyone later.
Thank you.
Thank you.
See ya. Thank you.
Cheerio.
Bye.
Bye-bye.